Machine learning at its essence involves algorithms that analyze patterns in data and use those patterns to make predictions. In this course, we focus specifically on supervised machine learning, with a particular emphasis on classification. In classification problems, we work with dataset that consist of features, the input variables, and targets, the outcomes we aim to predict. These targets are also referred to as classes or labels. The goal is to find a function that maps these input features to the target outcomes. The input objects are represented by sets of values, known as features, which describe various characteristics of the borrower, such as age, income, credit history, and spending behavior. The classes, or labels, are represented by a set of symbols or nominal values, typically indicating whether the borrower is likely to default or not. Essentially, we are training our model to learn the relationship between the inputs and outputs, so it can make accurate predictions on new, unseen data, in our case on new loan applications. Now let's talk about two fundamental types of classification in machine learning: binary classification and multiclass classification. Binary classification deals with two possible outcomes. For example, in spam detection, we classify emails as either spam or not spam. In disease diagnosis, a model predicts whether a patient is diseased or healthy. In sentiment analysis, a text can be classified as having a positive or negative sentiment. On the other hand, multiclass classification handles more than two possible categories. Some examples include animal recognition, where a model might classify an image as a cat, dog, or bird. Weather classification, where conditions can be labeled as sunny, cloudy, or rainy. Product categorization, where products can belong to categories like electronics, clothing, or books. In this course, we will focus on binary classification, learning how to build, train, and evaluate models that can solve real-world problems, such as credit scoring. In this course, we built a credit scoring model based on the prediction of loan defaults, which belongs to binary classification. In this scenario, our classifier takes in various features about a loan applicant, such as their age, employment status, income, credit history, and loan details. Based on these inputs, the model predicts whether the applicant is likely to default on the loan or not. As shown in the diagram, the classifier processes these features and produces one of two possible outcomes: non-default, meaning the applicant is likely to repay the loan, and default, meaning the applicant is at high risk of missing payments.